And so, yeah, super pumped to introduce our first guest here today, Manveer Basra from Prime Intellect, talking about decentralized AI and the science bridge there. So, come up on stage, welcome. Give a little bit of a welcoming applause here for Manveer. Yeah, stage is yours.
Hello, hello. Hoping you guys can hear me all right. Yeah, all right. Yeah, I was talking to some guy outside who he does Toastmasters every week. He told me when I come up on stage to wait 5 seconds before speaking. So that was me. That was the pause there. But yeah, excited to be here. So curious from the audience, like how many of you know what Prime Intellect is? Okay, bet not many. Okay, so hoping I'll show you guys something new today. So yeah, one sec. Perfect. Okay. So if I was in the audience, I think the first question that I would have is why is a decentralized AI project presenting at the DeSci Summit? I think there's a lot of decentralized AI projects out there. Very few probably have like very strong synergies within DeSci. So to add some color to that question, I'll start with the background on the team itself. So our core team has like pretty strong roots within decentralized science. So many of you probably know who Vincent Weiser is. He's been pretty heavily involved in the molecule Vita DAO as well as BioXYZ ecosystem. Same for Johannes as well too. He's done a lot of scaling of LLMs at Aleph Alpha, but has also been involved in Vita DAO. And then myself, DeSci is also my first love too. Around 2 years ago when I wanted to start my own startup, it was within the DeSci space. I got angel backed by Balaji Srinivasan to build decentralized research publication. And then also shortly after worked at Research Hub, which is Brian Armstrong's effort in the DeSci space, which I think they're also presenting today too. So that's all to say that we do have very strong ties within decentralized science, and we see our mission of decentralizing AI and accelerating AI progress in service of accelerating scientific progress more broadly. So yeah, what is Prime Intellect? The one-line mission statement I may give to you is that we are trying to accelerate an open and decentralized intelligence future. There's probably like 10 other decentralized AI projects that have this exact like mission statement. So it can sound a little bit amorphous. So I'm going to try to add a lot more color to it by talking about what we're actually doing to execute on this. So the core of Prime Intellect, there's like 3 main pieces of what we're doing right now. One is we have a compute exchange. 2, we're working on making decentralized training work at scale. And then thirdly, we're building a protocol to enable collective ownership, creation, and governance of open and decentralized AGI. So I'll walk through each piece independently. The core of our platform is a compute exchange. I know it's a little bit boring, but you can basically come to our platform, get up to 256 H100s on demand. And the way that we're able to do this is we aggregate a lot of GPU providers, including many you've heard of, many you probably haven't heard of, Akash Network, RunPod, Lambda Labs, and whatnot. And as a side note, because we have all this compute available and because we know about the problems within scientific research, we've been involved in DeSci, we also know that there are a lot of high impact but underfunded scientific ideas that are out there. And so we're trying to leverage some of the compute that we have to even fund some of those ideas. So for example, we work with some researchers out in California on training a metagenomics foundation model for pandemic safety recently. And if you subscribe to Vitalik's DIAC aligned thesis, I think a model like this can have a lot of impact in the future. And so yeah, the second piece of what we're doing is we're trying to make decentralized training work at scale. So decentralized training, it's essentially being able to train models with GPUs that's distributed across even continents. This is a very hard research and engineering problem. Even if you're just training with H100s across different continents, because you have very low communication bandwidth between each, GPUs can die, drop off at any time. You have heterogeneous compute too, so like different GPUs can run at different speeds as well too. But we're making some pretty good strides on actually making this work. So recently we released our research paper where we trained a 1 billion parameter model across 4 data centers on different continents. And it was able to achieve the same performance as if it was in a single data center. And we're trying to scale this up 10x, and we think it can scale up really quite massively from there. And the third piece of what we're working on is a protocol for the collective creation, ownership, and governance of intelligence. If you're familiar with Molecule's IP NFTs, it's really quite similar. We want to enable people to collectively fund and own the resulting IP and output of the AI models that they fund. And so these 3 components together form the foundation of our master plan. So our master plan is basically three pieces. We want to aggregate global compute. So this is, we want to get thousands of H100s onto our protocol. We want to get millions of consumer GPUs as well too. In order to scale decentralized training, have it really work at scale, and be able to train really large scale models in a decentralized manner. And then leverage these 2 to build open and decentralized AGI to accelerate progress and scientific progress as well too. And the way that we plan to do this might be a little hard to read, but the way that we plan to do this very concretely is leverage the compute that's on our network to, basically we subscribe to the bitter lesson sort of thesis by Richard Sutton that basically it's a hypothesis that most progress in AI comes from just more compute and more data. And so what we're doing is we're leveraging the thousands of H100s that are going to be joining our protocol and using that to train large-scale models in a decentralized fashion. And then the consumer compute that's joining our network, it's unfortunately not practically feasible to train large-scale models using consumer compute because it is slow, there's a lot of communication overhead. But we think there's a really big opportunity to leverage consumer hardware that's out there in order to do synthetic data generation to basically fulfill the data component of this compute and data thesis. And obviously, this is ultimately within the goal of training decentralized AGI. You may ask why we're doing this. I feel like a lot of these reasons are quite trite, like people have talked about them quite a bit, so I'm not gonna, I'll just like gloss over them for the most part. Obviously, you know, we want to prevent monopolistic AGI. We don't want like a few nation states or a few companies having control over superintelligence. I think polytheistic AGI, which is something that Balaji talks about, is a much better future. Obviously, open source is also just a much better way of building software. It's just much more secure. I think there's some interesting things that we can do as well in the realm of collective governance. And the final piece is that the main reason, even why we're presenting here, is because we think that AI will drive a significant amount of scientific progress in the future. The most concrete example of this is, I don't know if you guys have seen the AI scientist that Sakana AI Labs came out with, but basically it was an orchestration layer on top of a model, an orchestration/agent layer on top of a model that enabled them to generate novel research papers. The research papers themselves, they weren't that interesting. They had a lot of issues in them, but you can assume with like, or you can see with like an order of magnitude improvement or 2 orders of magnitude improvement in the underlying base model that an infrastructure like this could be really quite powerful. And this is the sort of thesis that we have, that we think a significant amount of progress in the future, scientific progress in the future, will unfold because of AI. And this is partly why we think that the destinies of decentralized AI and decentralized science are quite intertwined. I think in order to ensure a future, a decentralized future of science, we're going to have to need decentralized AI as well too. Because the alternative is that AI is centralized, AI is controlled by a few nation states, a few companies, and as a result, scientific progress will unfortunately be owned and directed by a few companies. And so we want to help ensure that both the future of AI and science remains open. And I think there's a lot of opportunity for us to work together on that front too. A last call to action before I wrap up. We are going to be experimenting with our first decentralized training runs on creating this open AGI that of like the thesis that I talked about before. And we're also wanting to train in a decentralized fashion other interesting models as well too. So if you, one, have interesting model ideas that you think could benefit from a lot of compute. I know there's a lot of interesting underfunded ideas out there. We obviously want to see those. And then secondly, if you're interested in contributing compute to decentralized training runs for our incentivized protocol experiments, please do reach out. I guess to wrap up, we are also hiring too. So if you want to work on a decentralized AI project that's actually shooting to have real tangible impact within the real world, both in the scientific realm, but also in the AI world, please do reach out. My Twitter is there, our company's Twitter is there. I am more than happy to connect you guys and like maybe see if we can work together. Thank you.
Yeah, working? Check. Cool. I think we have 1 or 2 more minutes, so I want to allow the audience, if anyone has questions, to raise them. There we go.
What are the advantages of doing your scientific compute over a decentralized compute network versus just a centralized? Is there any extra added layer of privacy or trusted execution environment that comes with it?
Yeah, so those are some things that I think are definitely feasible in the future. The thing that we're looking at right now is we're trying to make decentralized training as competitive with centralized training as possible. So we're trying to limit the compute overhead that comes with doing things in a decentralized fashion. Like trusted execution environments, for example, are like a pretty compelling solution that you can actually have models being trained in a fully private manner, even if you have distributed compute joining those clusters. The only issue is that there's not a lot of compute out there that can actually be booted in confidential compute mode. Even though all H100s have the ability to do it, you actually need a corresponding a proper AMD or Intel CPU in order to do that. But in order for our decentralized training runs, basically the way that we're structuring it is that if you have a very compelling model that you want to train and you can evangelize that to a community and people want to contribute compute to that, you can basically get free compute arguably in return for ownership of the model that you create.
Cool. Thank you so much, Manveer.
Thank you all.
Yeah, give a round of applause for this awesome talk.